I mean, what could really go wrong here? By the time we're done, we will delve into common physical issues that occur with copper and fiber optic cabling. Delve. Obviously, I was in a thesaurus this morning, and I'm like, yeah, that's the word. So the truth be told, there's a lot that can go wrong with this cabling, and one of the challenges is it's the last place that you think to look. Most of the time, people don't come and say, hey, there's a bad cable there, right? It'll come across as like, hey, the network seems slow. Oh my goodness, where do you begin even troubleshooting an issue like that? There's so many possibilities of what it could be, one of them being the physical characteristics of these cables. So let's dive in. Let's look at two different cable types. This is fiber. Obviously, somewhere around here, I've got, there it is, copper cable. And what could go wrong like that? So as you may or may not know, Ethernet, or Category 5, Category 6, 7, etc., cable has two different major standards that you can use for wiring. It's called T568A and 568B. These are the order of the pins that you should use. When I first got into networking, I made my own cables. Everybody should do that at some point. And I had no idea. I was just like, okay, well, as long as pin 1, 2, 3 match on both sides, we should be good. And I actually wired a whole bunch of my house not using any standard whatsoever, and most of it didn't work. When you wire these up, and I'll explain why I've got this funky cable like this. When you wire these up, the electrical signals that go over the cable actually spin inside of the cable. And that's one of the big differences between Cat 5, Cat 6, Cat 7, is how tight the twists are inside of the cable. These 8 individual wires actually twist around each other. And when you send electrical signal through those twists, it creates an electromagnetic shield. I'll just put EM, electromagnetic shield, which protects it from interference, both on the outside of the cable, so evil signals trying to get in and mess up your cable on the outside, but also on the inside of these cables, these pins interfering with each other. One of the other unique things that you'll notice when you actually get into cabling is if you strip this shielding off, the twists are a little bit different. And I don't know if you can even see it right here. The blue cable, the blue wires, I should say, are twisted kind of tight. The brown are twisted a little bit looser. That's on purpose. They do that to keep the electrical phases out of sync with each other, so it minimizes the interference that these things can cause within themselves. So a lot of the challenges that you might have with these cables deal with, first off, miswiring, as in you crimp your own cables, or you purchase a crimp cable that it has not been tested, and somebody has not wired them to the T568A or B standard. By the way, when you have T568A on both sides or B on both sides, that's considered a straight-through cable. I'll just write it like this, straight through. If you take T568A and on one side and B on the other, you create what's known as a crossover cable. In the old days, oh my back, devices used to require that you would use a crossover cable when you were connecting like devices, like a switch to a switch, or a hub to a hub, or a computer to a computer, because it actually will flip the send and receive pairs so that the send over here connects to the receive over here, and they can actually communicate. But long ago, somebody developed a standard called MDIX. It's actually written like this, and they incorporated that as part of Gigabit Ethernet. So every Gigabit Ethernet interface has the ability to auto-detect what is used on the other side in terms of send and receive, so you don't need the straight-through crossover thing anymore. You can use actually either one, and the devices will figure it out. The second thing that can happen is a dead wire. These are really thin copper cables, so over time, as you bend them and twist them and things like that, the copper inside of them can become weaker. And so, if it becomes loose or disconnected, you can end up with a bad cable. Now, typically, and one of the things that you should know, and let me explain why I've got this messed up cable. By the way, I hate it when people do this, where you've got the shielding and it ends, and then you've got this nice little stretch of the individual wires. That is definitely case in point of a cable that will likely go bad. Not only do you undo the twist right here, so it'll cause interference with each other, but this is just a weak point of the cable where you can have a break or dead. So let me explain what this cable is. This cable actually represents 4 hours or so of work. I'm going to post something on social a little bit later today on YouTube. My mission was to create a mostly dead cable, one that would give you signal but actually cause all kind of interface errors. And I actually did that for this skill that I'm creating right now, so that that we can actually see how we can detect a bad cable, and I can show you all kind of packet counters and things like that. So more on that later. That's why I have this cable all messed up like this. But inside of the cable, only 4 of these wires are used to send data. It's 2 pairs for send and 2 pairs for receive. So that's why it will still work even though I have these stretched out. A lot of times these will be used for things like power over Ethernet, to send power down the line and power like a wireless access point, a phone, a camera, whatever else we can plug into the Ethernet cable. So when I say dead wire, I'm really focused on those 4 individual wires. And if you're following the standard, the 4 that are used for transmission are 1, 2, 3, and 6. 4, 5, 7, and 8 are not used for actual data transmission, at least in what I would call standard gigabit Ethernet. The length of a cable is a thing. 100 meters, or 328 feet if you're in the United States, is about the maximum that they can go. Now, it's not like you reach that 328 feet, and if you go 329, it's like, oh, dead cable. It's one of those things where it will work further oftentimes if you run it well, but you might get a little packet loss, and the further and further that you go, the worse and worse it gets. Now, I mentioned that these wires spin electrical signal around so that they can create an electromagnetic shield, but that doesn't make it perfect. When you run these cables alongside strong electrical competing signals, that could be other Ethernet cabling, which maybe has a little bleed through from the shielding. It could be a fluorescent light. It could be, it was funny. I worked for a company a long time ago that around lunch, there would just be really bad network performance. And what we found out is somebody in the wall of the break room had actually run a big bundle of cabling behind the microwave. And so when people were microwaving their food, you'd get all kinds of interference, and it would cause packet loss. Do you see why I'm saying there could be so many things that go wrong down at the physical layer? Last one is exposure. These cables should be tucked away someplace safe. Obviously, if you've got them in the sunlight, like I'm staring out right now at a camera I mounted outside, a webcam. I call it a webcam, video surveillance, right? And I can even see the Ethernet cable going up into the rafters, and I'm like, as the sun goes down, it's hitting the cable. That's literal exposure. But also having them run across the ward, sometimes people put those little protectors over them so the rolling chairs don't hit the cable. Those kind of things, just having Ethernet cable exposed means it's going to probably get messed with or snagged or something and cause all kind of damage. Now, when it comes to fiber optic cable, it's pretty much the same stuff. It's just things get a lot more sensitive. These are plastic if you're using multi-mode, or glass if you're using single mode. It's not that you can't bend them, but you can't bend them up to a point. Whereas if you've got your copper cable, you're spinning this thing around your arm. Yes, it's sensitive, but nowhere near the same as fiber optic cables. So in my experience, the number one most common error is a miswire. Now, it's like, there's 2 lines. Why would there be a miswire if there's only 2 wires? Well, it's because it's not marked. It's not like, we've got our, T568 A and B. It's, the orange stripe orange, green stripe blue, blue stripe. There's a common standard that people follow with that, and everybody can look at the colors and easily see if it's miswired. This is the same color, and one side is literally the send, and one side is the receive. I'm kind of tangled up right here. So one of these will be the send, and one of these will be receive. Now, you might be like, well, you just click them in. Well, this is a little, what do you call them? Like a fastener? A fastener that keeps these 2 things the same. A lot of times people will take it off, whether it be for testing or they're trying to fish it through, a small hole that they're in a wall or something like that. And at that point, you don't know which side is send and receive, and it's not easy to follow, especially if you're going a distance, which matches to which. So in a typical fiber cable, these lines will roll. So this side would be send and receive, And the opposite side would be receive and send, right? So it kind of matches. I think it's like a positive negative, So one side's listening, the other side's talking on the cables when you match them up. Most common thing, and the good news is it's really easy to fix, but I've seen a lot of times where people will come to a data center or something and they'll plug it in and they'll leave. They don't have enough knowledge to test it or see that it's working. And all it takes, they call it rolling the pairs. That's the phrase you'll hear in fiber. You roll the pairs. You roll them to where they're mismatched to the wrong side. Dead, damaged, pulled. You can't pull a fiber cable. If you do, you're gonna probably disconnect it from, and when I mean pull, I mean like trying to get it. I can't tell you how many times I've done that with the copper. Just a couple more inches. So these are again really sensitive. So it's really easy to end up killing them or damaging them when you're trying to fish them through walls. A misconnection is also really easy to happen. Again, these are sending light. So you've got your clips that clip in there, and if this at any point is off, I mean, think of how it's a laser. I mean, it's a really thin laser. So if you're off just a tiny bit, you can end up missing the transmitter, the connector in the interface that you're plugging it into, right? So you got to make sure that everything lines up perfectly. These last two are exactly the same as copper cable, exposing them to the elements or running a cable that's too long. Yes, fiber optic can run longer than Ethernet, but there's still a limit of how far that light will go before you have to regenerate it. Keep in mind, that's one of the unique advantages of fiber. On copper Ethernet, you hit a limit. You can only regenerate it so often or so many times before you introduce too much noise in the line. Whereas light, you can add regenerators that will allow it to go around the entire planet. That's why we have an entire connected planet. There's even fiber optic running under the oceans, transatlantic fiber. You might read a Wikipedia article on transatlantic fiber. They're trying to figure out how to get sharks. It's fun. So obviously, this is just a high-level view. I didn't even talk about sharks because you and I don't deal with sharks on a normal basis. But these are all the things that can affect the copper and fiber cables on a physical level that most people never even think of. That's why it's so good to plant that seed of awareness so that when you're troubleshooting an issue and it seems like all other things have failed, check the physical characteristics. I hope this has been informative for you, and I'd like to thank you for viewing.